Hey everybody, today's lesson is lesson 3.4 out of the book, and the lesson today is about using similar triangles. Now the purpose of using similar triangles comes down to angles. It's going to let us know if angles are congruent. Now the word congruent means that they are the same. I think first we need to discuss the fact the word similar here in our lesson title, similar triangles. These triangles that I've drawn, they are similar. Now, if you can see, I've tried to draw them the best I can. Their angles are going to be the same, and I'll show you that here in a moment. But you can see that the triangles themselves are different sizes. So similar means that the triangle has the same shape, but not necessarily the same size. The word congruent, because we want their angles to be congruent, means that they are the same. So if we look at triangle ABC, and here's how we would write that, triangle ABC. I need to put some angles in so that way we know what these angles are. Angle A is going to be 65 degrees. Angle B is 95 degrees. And angle C is 20 degrees. Okay, so there's the degrees for triangles ABC. The next triangle is DEF, and guess what? If these triangles are truly going to be similar, then these angles will be equal to these ones. So where we have angle A, angle D would be the congruent angle. This is going to be 65. Angle B is going to match up with angle E, so that's going to be 25. And angle C is going to match angle F, and that's going to be 20. So if we get a case like this, where the triangles are the same shape, not necessarily the same size, but the same shape, and all of their angles are equal, then we're going to say that triangle ABC is similar, and that's the symbol for similar. Triangle ABC is similar to triangle DEF. Okay, so that's what makes triangles similar. Again, they don't have to be the same size, but they do have to be the same shape, and their angles need to be congruent. All right, so now let's take this information that we know and let's put it into practice, because again, the title is using these similar triangles, and we can use them to actually find some angles. So let's start off with an example here. I'm going to call this example 1. And I'm going to make the triangles, let's see, I'm going to make this angle a 75-degree angle. And I'm going to make this one a 50. And I'm going to call this one X, angle X. I'm going to make this triangle be turned a little bit differently, but I'm still trying to give it the same shape. Even though it's turned a little differently, that's okay. I'm going to say that this is the 50-degree angle side, this is the 75, and I'm going to call this angle Y. So the question would be, and I'm just going to put a big question mark, are these triangles similar? Well, let's take a look. This triangle has an angle that's 50. This triangle also has an angle that's 50. This triangle has an angle of 75, as does this one. And that means if they have two angles the same, that means X and Y must be equal to each other. Because if you remember back to our past lessons, we know that all of these must equal 180 degrees. All of these must equal 180 degrees. And if two of the angles are the same, then the third ones must also be the same. So we can say, yes, these triangles are similar triangles. Let's try another one. I'll call this example 2. With example 2, take this triangle, and we'll take this triangle. I'm going to use this symbol. Remember that is the symbol for 90 degrees. I'm going to call this X. This one's going to be 42. I'm going to call this Y, and this is going to be 38. Okay, so the question again, and I'm just going to put a question mark beside it. Are these triangles similar? Well, to really figure this one out, we do need to do some math. And it doesn't matter which triangle that you do, but you only need to do math for one of the triangles, so that's good. You just need to pick one. I'm going to pick the first one just because I wrote it first. We need to set up the equation to figure out what x is. Okay, I need to figure out what this one is. So I'm going to say, we've done this in the past already, x plus my 90 degrees right there, plus my 42 degrees right there, all will equal 180 degrees, because remember in the past lessons, we know that triangles, interior angles equal 180 degrees. I can then combine my like terms, and I'm going to end up with x plus 132 equals 180 degrees. To get x by itself, I need to subtract 132 from each side. That'll cancel out on my front side and leave x by itself, which is my goal. And if you have a calculator, you can do this on paper. 180 minus 132 should give me 48. Okay, so now I know I just solved for x. I know that x is 48. Now I can compare. I have a 90, I have a 90, I have a 48 and a 42. That 38 does not match up with either of those. So the answer, are these triangles congruent? Or I'm sorry, are they similar? The answer is no, because their angles do not match up. Okay, one more example that I want to show you. We'll call this example 3, and this will be the last example, and then you'll have a little bit of homework. I just want to give you a drawing if you would ever see a problem like this. I'm going to call this triangle A, B, C. And then I'm going to draw a line right here, and I'm going to call this K, L, and I'm going to put those marks like that. Okay. Now, what I have actually drawn here is 2 triangles. I first drew triangle A, B, C. That's the big triangle. So the first triangle was triangle A, B, C. And I drew a second triangle after that. I drew triangle A, K, L. A, K, L. So I'm going to write that. Triangle A, K, L. That's a smaller triangle there. Now, if you're ever given a problem like this and they want to know, question mark, are these triangles similar? You need to pay attention to these little markings right here. Those markings mean that lines L, K, and B, C, they are parallel. That means they're never going to intersect. As long as those lines are parallel to each other, then this triangle, both of these triangles, are similar, because this angle is going to equal this angle, and this angle is going to equal this angle, as long as those lines are parallel. So I just wanted you guys to see that example. These lines have to be parallel for the triangles to be similar. Okay, so there is the lesson today, using similar triangles to work through different angles. Now I have 4 homework problems for you. Okay, so your homework today, tell whether the triangles are similar, and here's the biggie. Not only do you have to tell me if they're similar, but you have to explain. If you say, yes, Mrs. Dean, they are similar, then you better be telling me that their angles are equal or congruent. If they are not the same, then you need to tell me which angles aren't the same. All right, so here's problem number 1. We have 2 triangles here. We have a 39-degree angle, a 34, and then we have angle X. On this one, we have a 34-degree angle, a 39-degree angle, and an angle Y. You are telling me, I'm just going to put a question mark out here, are those triangles similar? Why or why not? Number 2, we have a 72, a 36, and an X. And in this triangle, we have a 72, a 33, and a Y. Are those triangles similar? Why or why not? Problem number 3, we have a 64, an 85, and an X. And we have a 26, an 85, and a Y. Are those triangles similar? Why or why not? And last but not least, we have an 81, a 48, and an X, a 51, a 48, and a Y. Are those triangles similar? Why or why not? So there's your homework. Make sure that you explain. And like I tell you every week, if you have any questions about this material, about this lesson, just message me on Live Grades and I'll be happy to help you. Have a good day. Bye.